second. Okay. All right. So the next thing we're gonna talk about voltage. Okay. Now voltage produces the flow of charge, and it's measuring volts. Okay. So what that means is that voltage does not go through the wire. What goes through the wire is actually the current. Okay. Now this voltage or volts are measured. They're measuring volts, and we're going to use the V to represent what the voltage. Okay. And the only time we have an actual we have voltage is or different or electric potential here is when there's a potential difference between the ends of a conductor. Okay, just like potential energy. The only time you have potential energy, if we're looking at height, is when you start moving that ball, that object, high enough to where there's a difference. Okay, all right. So potential difference, okay, is provided by a voltage source, and those a voltage source could be a battery, a generator, or a dry cell. Anything that can give voltage, or that can put the pressure, or what can provide the pressure, okay, to these electrons to move, we're gonna call it voltage. Okay, so again, voltage just provides the electric pressure to move electrons. So voltage does not flow. Current flows, and it flows because of the voltage that's being applied to that circuit or to that current. Okay. All right. So resistance, the another thing that we have to talk about today before we do more problems. Resistance is just the resistance to current flow. So if there's something in that circuit that's going to resist the current flowing through the circuit or to the wire, then we're going to call that resistance, and we're going to use R to represent resistance. And resistance equals voltage over I. Okay. The V in the formula it stands for electric potential or voltage, or in volts, right? And then the I is the current in amperes. Now resistance is going to be measured, or the unit is going to be measured in ohms. Okay, that reverse horseshoe or upside down horseshoe on the drawing that you see there. Okay. Resistance depends on the conductivity, the length, and the thickness of the conductor. And this, we're going to come back to this after we talk about circuits. We're going to talk about resistivity and how the length, the thickness, or of the conductor actually affects the resistance of a lot of these resistors. Okay. All right. So that's the formula, and this is what we call Ohm's law. Okay, so Ohm's law is just states that the current in a circuit is directly proportional to the voltage and inversely proportional to the resistance. What that means is this, that you need to remember this little triangle right here so that you don't have to be thinking about all these formulas. Okay, but if you look at this formula right, where is it? Let me see. Okay, let me use this pen. If you look at this formula, you see that the current is proportional to the voltage and inversely proportional to the resistance. What that means is that if you increase the voltage on this circuit, then you're going to increase the current. Okay, and if you increase the resistance, then you're going to decrease the current, because they're inversely proportional. And that's what that means. Okay, so again, remember that triangle so that you can use it for your problems, and you don't have to remember three formulas. Okay, all right. So electric power. Now we know about Ohm's law. Ohm's law just gives us the voltage equals IR, or that little triangle that we looked at. Okay. Now electric power is the product of the current and the voltage. What does that mean? Well, that just means that power is the rate at which electrical energy is converted into other types of energy. Okay. Remember, we don't create or destroy energy, but when you plug in your lamp into the outlet, you're actually changing that electrical energy into light energy, noise energy, heat energy, because some light bulbs are make noise. If you get close enough, you can hear it. Okay, so that's what power is, and that's how we represent it. Now, there's three equations for power. The first one is, I guess, if you go, let me use this right here, right? This one right here, it says power is the product of the current and the voltage. Well, you see that in the very first one. Okay, now on the second one, you can see that from if you take the I, Okay, let me prove it for you right here. So for this one, okay, we're looking at that one right there. Okay, for that one you would have uh, P equals IB, right? But we know that if we look at our little triangle, okay, B I, sorry, I'm using my fingers for this, but you know that I equals B over R, okay? So if you put that instead of the I, then that would give you B squared over R, and that's how you get this equation, okay? All right, so now let's do the second one, or the third one that you see there, okay? Let me keep this. Okay, so now if we instead of if we leave the I there, but we look at what voltage is, voltage, if we look at our triangle, is actually IR, okay, and we multiply that, then that's going to give us I squared times R, and that's how this one comes about, okay. All right, so that's why you have three equations for power. You can either write them all down, or you can just remember how to solve that with your triangle. Again, your triangle is very important for you to remember, okay. Power is measured in watts, and also, when we're looking at energy, you gotta remember, you gotta be able to convert into kilowatts. And 1 kilowatt equals 1,000 watts, or 1,000 watts equals 1 kilowatt. Okay, your electric companies, okay, charge by kilowatt hour. They don't charge you by how many electrons they're actually getting to your home. They charge you by the amount of kilowatts that you're getting from them per hour. So let's do this problem real quick, okay? Let's say that you're paying 20 cents per kilowatt hour, and you have a 100-watt light bulb, okay, and you plug it in, or you're burning that light bulb for 10 hours. How much money does it cost? Well, let's do the first thing that we need to do is change those 100 watts into kilowatts. Okay, remember, we're going to be talking about kilowatts because that's how they sell this energy, or this this energy. Okay, so we have zero point 0.1 kilowatts. Okay, now we multiply by hours, because that's how many hours we're actually going to have, and I think I put 20 hours on here. So so this right here, make sure you have that as 20, okay? Because I multiplied by 20. I was thinking 20, but uh, I don't know. Instead of 10, I put 20 down here, so just fix it in your problem, okay? So that gives us 2 kilowatt hours, and once we do that, okay, we can multiply that by 0.2, or by 20 cents, or $0.20, okay, which costs every kilowatt hour, and that gives us 40 cents. So if you keep it on for 20 hours, you would have to pay 40 cents. So if you go back to the original problem and we do it with 10 hours, that would only make you, you would only have to pay 40 cents, okay? So that's how you solve these types of problems.